Okay, so when we talk of, you see, these are three different forms of equations, or these are the general, how generally equations appear to in questions. So they are equations because of the equal signs here. That's the first thing you should know as a student. You should know that it is an equation because of the equal to sign. Without the equal to sign, it's just a mathematical expression. Do you get it? So the topic can be quadratic expressions or equations, but if it is equation, which means it is specific to equal signs. Okay, so this is it. And also the second thing you should know is that with this first one, it is called a linear equation because the variable, okay, let me come here. This is a variable x, ax plus b. A is called a coefficient of x. That's the coefficient of the variable, and the x is the variable. B has no variable, it is devoid of a variable. So B is called a constant number. So in mathematics, normally a variable is any thing that accepts output and changes the nature of an expression. Do you get it? So if it's defined as, for instance, if we have 2x plus 1 and we define x as 1, it will change the nature of this expression to 3. But if we have 2x plus the same function, let's say f of x, the same function, but this time around we define x to be 2, the nature of the expression will change to what? 5. You get it? So a variable is anything that when it is defined can change the nature or the output or outcome of an expression. Please, you get it? Okay, so as I said, the first equation is a linear equation because the x, which is the variable, has an exponent of 1 or a power of 1. And the second one is a quadratic equation because the x has an exponent of 2. The third is called cubic. But we are just focusing on this one for the purpose of this course. We are just emphasizing on the quadratic equation, which is ax squared plus bx plus c, which is equal to 0. So quadratic equation, and as I said, without the equal to sign, it is just a mathematical expression. So we can call it a quadratic expression. So this is how generally a quadratic equation looks like. And to solve questions under quadratic equations, there are basically 3 methods that you can use. The first one is using the factorization method. Factorization method. And the second one is using completing of squares method, and the third one is using the general quadratic equation formula. Formula, normally known as the almighty formula. Okay, so you can use any of these 3 methods. Okay, so basically this is have a quadratic expression, a quadratic equation. So we are going to use, I know that most of us were taught this formula, this method, that's a factorization method. And even some of us find it difficult in solving questions under factorization method. So we are going to start with the factorization method, then we'll do completing of squares. Okay, we'll use the completing of squares method to prove the general quadratic equation formula. Then maybe in a later video we will focus on the identities, which is alpha, beta, and the rest. So let's start with this one. So the factorization method. Okay, so with the factorization method, this is how we solve it. The first thing you do is you see, this is how generally a quadratic equation looks like. You get it? This is how I'm using this to teach you. Then we'll use this as an example. Okay, so the first thing you do is you multiply the coefficient of x squared, not x squared, which is a, by the constant number, which is c, so that you get AC. That's the first approach. Then the second thing you do is you find factors. You find factors of AC. So you find them, there will be a list of numbers. So you find them, which we don't know. I think it can be 1. Let's use this. So maybe 1 AC. Okay, 1 A, C, and AC. Let's assume these are the factors of AC. 1 A, C, and AC. So when we get these factors, the next thing we do is we look for any of the two factors that when we add we'll get the coefficient of x, which is b. So select any of the factors can be positive and negative. But if you are taking with respect to positive numbers, it should be positive throughout, or negative, it should be negative throughout, unless the product gave you a negative number. That's when if the product of A and C gives you a negative number, then you can take a positive and a negative number. But if it gives you a positive number, then when you are doing it with respect to positive numbers, you take only positive numbers, and if it is negative numbers, you take only negative numbers. So the third point, I said that you select any of the two. Sorry, you select, you see they come in pairs. You know that one will multiply AC to give you AC, right? So one moves with AC. Do you get it? And A will multiply C to give you what? AC. So A moves with C. So you select any of the two pairs. You see, this is one pair, this is another pair. But normally with other, this is just an example, but with other questions, you get more than two pairs, or you can get 4 pairs, 3 pairs, and many more. So you select any of the pairs. Let me say pairs. That's when you add, you get the coefficient of x, that's b. So this is basically what we do. So you select any of the two that when you add, you get the B, and you are good to go. So let's use this as an example. So we have a question like x squared plus 2x plus 1 being equal to 0. So the first step says that we multiply the coefficient of x squared by the constant number. And please, you see this is x squared. Since there is no number here, we know that x squared times 1 is equal to 1. Is equal to x squared. Do you get it? So we assume that there is a 1 in front of that x squared or that variable squared. So the the coefficient of x squared here, which is the a, is 1. So we'll get maybe 1 times the constant number, which is 1. So 1 times 1 is 1. Do you get it? Then you find that's the second method. So this is the first one. AC is equal to what? 1. Then the second one says we should find factors of AC. So factors of 1 is equal to 1 and 1 itself, but it is positive or negative. And I told you that since the number you are finding is a positive number, if you are doing it positively, you should do it positively throughout. And if it is negatively, you do it negative throughout. So since we are taking 1, and even it is only one pair that is here, so we know that it's either we add 1 and 1 to get 2. And this 2 is already here. That's the coefficient of x. That's the b, the coefficient of x. So what we are doing is, this is called a trinomial. In mathematics, the addition and subtraction sign separates terms. So for instance, in every expression, there are terms. This is the first term, this is the second term, and the third term. So the additions here are separating the terms from one another. Do you get it? So this is the first term being separated from the second term by this addition sign, and this one too has been separated from the third term by the addition sign here. So we have 3 terms, and since there are 3 terms, we call them a trinomial. So to expand a trinomial, you have to make it 4 terms, and to make it 4 terms, you have to break down the middle term into 2. So you split the middle term into 2. That's how we do it. And to get that, you have to go through all this to arrive at the 2 numbers you can use in splitting them. So now that I have the 2 numbers to be 1 and 1, because I said when you add them back, they should give you 2. Do you get it? So here we get x squared plus 1, but we represent it by x plus another x. And you know that when we add this, we'll get the 2x plus 1 being equal to 0. So from here we just expand. So we factorize the x out. You see, there is x here already. This is x squared. X times x, which is x squared. So when you bring one x out, you'll be left with another x. Do you get it? So this is the x, so I'll be left with another x here. But we are factorizing this way. Do you get it? So since I've taken one x out already, which means the plus will still be there, but since the x is out, it will be left with 1. Because we know that x times 1 is equal to what? X. So since the x is out, we still have 1 here. And one thing about factorization, this method, is that you should make sure that the ones in the bracket, when you factorize your figures out, the ones in the brackets are the same. So since here is x plus 1 and we already have x plus 1 here, we can multiply it by 1. Do you get it? Another way you say it is you factorize 1 out. When you factorize 1 out, you will still be left with x plus 1, because 1 times 1 will give you 1. Do you get it? And here will be 0. So you can take this and this, or any. Yeah, you take the one of the ones in the bracket first. Do you get it? then one of the ones in the bracket, then you take the ones outside, and you are good to go. So since it is an equation, you don't end here. You come back to say that x plus 1 is equal to 0. X plus 1 is equal to 0. X is equal to negative 1. X is equal to negative 1. Because this will cross to the other side of the equation sign. This one to crosses. And since it is addition, when it goes to the other side, it becomes subtraction. Okay. Okay, so we are done with the first method. So we are going to use using completing of squares to prove the general quadratic equation method. Then we'll use it in solving questions. But I don't think I'll give an example of the general quadratic equation method. So with that one, from the proof, you can still use figures or questions to go through that one and get your answer. But that one, normally it is not exam when it is not advisable to use that method for exam purposes because it's long. So let's just know the proving and we are good to go. Okay. So this is the general quadratic equation formula. Okay. So this is the completing of squares method. So the first thing you do when you are given this equation to prove the general quadratic equation formula. And this is the general, I want to write it somewhere. Minus b plus b squared minus 4ac all over to a. Okay, so we are going to prove this formula using this. So to prove this, the first thing you do is you divide this is the first step. Make the coefficient of x squared equal to 1. And so to make it equal to 1, you have to divide it by a. And I told you that in mathematics, the addition sign separates the terms. So since you are dividing it by a, you should divide each term by a. And also the terms at the other side of the equation by a. So here it is 0 divided by a. But you know 0 divided by a is still 0. So what we'll get is x squared plus bx over a plus c over a equal to 0. So the next thing we do is we take this expression. You see the first one, we splitted it. You know that it is still a trinomial. First term, second term, third term, making it a trinomial. Do you get it? And I told you that when we have a trinomial, we split it into two. Do you get it? So to split it into two, using the factorization method, we use an alternative. That one, it follows its own procedures. But with this one, to split this into two, you have to multiply it by half or divide it by 2. So you multiply this expression, b over a, that's the coefficient of x, by 2. So that it divides it into 2. You multiply it by half or you divide it by 2. You know that b over a divided by 2 is still the same as this. Because you reciprocate it to get this, then you multiply to get b over 2a. Do you get it? So this is what you get. Then you take the square of it. You take the square of it. So this is what we get. We get x squared plus. So when we get that, what we do is to add it to both sides of the equation side. So we can replace it by this. So we will replace this by the square of what we got. And we add it to both of the equation side. Or we, in other people, okay, let me do it this way. So you, first of all, we still have our b over ax plus b over 2a all squared minus b over 2a all squared being equal to, please, I'm bringing this to the other side of the equation. So it will be minus c over what? A. Because here it's already 0. So when we bring it there, it will be minus c over a. Please, you know that when I add this and this, it is 0. It is like 2 minus 2 is 0. They are the same thing. When you add, you get 0 because 2 minus 2 is 0. And any number minus that same number is 0. So it's actually, in actual sense, I didn't add anything to it. It has no effect on this. Did you get it? It has no effect on this. So we will replace this by these two, which will have no effect on it. So we can just take this one out. We will just take it out. So x squared plus b over 2a, because we've already splitted it into 2, being equal to minus c over a plus b over 2a squared. So this is where we get to. Then, since here is squared and here is squared, we can factorize out the squared. So we get x plus b over 2a all squared being equal to, there is no squared here, so you can't do the same approach here. So c over a plus b squared over, you just affect the square to each side. It's indices. So b to the power 2, this square here will affect the b here, and it will also affect the a 2a here. So 2 squared means 2 times 2, which is what? 4. So this will give us 4. And a squared is a times a, which is the same as a squared. We get it. So we'll get something like this. So when we get here, what we do is to find the LCM, least common multiple. So mostly the best way to find the LCM is just cancel the a out of this. So since a can be cancelled out of it, you can see that the LCM is 4a squared. Because this a can be found in 4a squared. This a can be found here. So you can take all this to represent the LCM. So the best thing to do, it is the normal mathematics we did way back JHS. So 2 over 3. So you know the LCM is 6. And you know that you divide the 6 by 2 to get what? 3. Then you multiply it by the numerator, which is 1, to get the number you write here. Then you have to divide the 6 by the denominator, which is 3, to get 2. Then you multiply it by the numerator, which is 2, to get your 4. Then you write it here, then you get 7 over 6. That's the same method we are coming to apply here. So we divide our LCM, which is 4a squared, by the numerator, which is a. And since a is here, a will cancel 1a, we will be left with 4a. So the 4a will be multiplied by the negative c. Then we'll get negative 4ac. Negative 4ac. So, as I was saying, let me do it here. Let me do it somewhere. We divide the LCM 4ax squared by the denominator here, a, so that we'll get 4a. Because here is 2a, so it is a times a. 1a here will cancel another a there, so that we'll be left with 4a. Then we multiply it by the numerator, which is negative c, to get negative 4ac. This is what we get. Then also, we'll do the same thing. So we'll write the negative 4ac here plus. We'll do the same thing for the other aspect. So 4a squared divided by the denominator, which is also 4a squared. So it will cancel each other. We get 1 times the numerator, which is b squared, to get b squared. So when we get this, then we write down 3b squared. And it is equal to x plus b over 2a all squared. X over 2a all squared. So, okay, so we continue here. So from there, I want to write that part here so that you will see clearly what we are doing. So since we are making x the subject, the best thing you can do is to omit the root, find the square root of this, so that we can cancel the power 2 here. Because we want to, when we find the square root of this, these two can cancel the root sign, so that we'll be left with x plus b over 2a being equal to plus or minus roots minus 4ac plus b squared all over 4a squared. So we continue x plus b over 2a being equal to plus or minus. Please, from here, I just want to interchange it so that it will look like this, because it's the same thing. It's mathematics. Even though addition and subtraction are not commutative. Addition is commutative, subtraction is not commutative, but you can write it this way, just that you know how to write it so that it will sing the same. So you get b squared minus 4ac. You get it. The negative still affect the 4ac and the positive is still b squared. But root 4a squared. So this root affects both of them, but I've split it into two so that you understand what I'm coming to do here. So here we get over 2a being equal to plus or minus root b squared minus 4ac all over. Please, the square root of 4 is 2. Square root can be seen as 4 to the power half. And you know that 4 can be also written as 2 to the power 2 times half. 2 to the power 2, but there is half there, so it can be 2 to the power 2 times half. Do you get it? So this will cancel this to be 1 times 1, which is 1. So we'll be left with 2 to the power of 1. And any number to the power 1 is that same number. So root 4 is also 2. This one, square root, you should just master them. But when you have your calculator, when you press root 4, you get your answer to be 2. So here you get 2. And root a squared is also a, because it is a squared times half. This cancels this. You get 1. 1 times 1 is what? 1. So a to the power 1 is still a. So here you get 2a. So I think from here we can just omit the bracket. So x becomes equal to, since it is positive, we are bringing it here because we are making x the subject. So it becomes negative b over 2a plus or minus root b squared minus 4ac all over 2a. And since the denominators are the same, we can see x is equal to minus b all over we can maintain just one of it, b squared minus 4ac all over 2a, because the denominators are the same, so we can just maintain one and square it for both of them. So this is the almighty formula and it has been proved. Okay, so this is just the proof. But actually, to go through this hell to solve a question is not advised, because normally you can just use this formula to solve the question. So the question we solved earlier, we can